Alright, this is a video for the Chapter 6 review. This will help you on the Chapter 6 test. This video will probably be 2 videos, so I'll do like the first half is one video, then the second half is the second video. I'm going to go extremely quickly, so make sure you follow along quickly. You can stop the video if you need to catch up. And as far as getting this paper into me, you can either copy, run off the Chapter 6 review because you don't have this as part of your packet, or you can just copy down the answers and send that to me by email or by a picture, whatever you decide to do. Just give me something that, with your answers for the Chapter 6 review. And again, this will help you for the test. So I'm going to start on this again. It'll be probably in 2 separate videos. The first one says find segment BC. So we're trying to find the length of segment BC, which is this whole thing down here. We know that this is a right angle. We know that these 2 segments are congruent. Our theorem said if these 2 are congruent and this is a right angle, then segment AD here has to be a perpendicular bisector, and any point that's on that perpendicular bisector, like point D is right there, has to be equidistant from the 2 endpoints of the segment. So that tells us that these 2 endpoints, or these 2 segments, have to be the same length. So we know this one's 15, then you should be able to find this one. And once you know that one, you're just going to add those 2 together to get the whole thing, and that will be your answer over here. So those 2 add together will give you your answer. Just put it over there on the blank. Most of these, as I do them, I'm not going to tell you the answer. All right, I'm going to leave it so that you can figure out some of it. Next one, same idea here. We know that this is a perpendicular bisector because these 2 segments are congruent. That's a right angle. And if that's the case, A is the same distance from B as it is from C, so these 2 have to be equal to each other. So the equation we can set up is 4x plus 6 has to equal 5x minus 6. We solve this, get that 4x's cancel out, you're left with 6 there, x minus 6, add 6 to both sides, and you end up with x equals 12. They ask us to find the length of segment AB. Segment AB is this segment over here. So all we got to do is take that 12 and we're going to plug it in. So 4 times 12 plus 6. Figure out what that is, and that's going to be your answer. Number 3. They say find the measure of angle BAD. This is angle BAD right there. We look at this, and point D is the same distance from this side of the angle as it is from this side, because both these are 7. We had a theorem that said if a point is the same distance, ignore that, if a point is the same distance from both sides of the angle, then that point lies on the angle bisector. So that tells us that ray AD there has to be the angle bisector. And if that's the case, if this is 23 and this is the angle bisector, then you ought to be able to figure out how much that angle is, because they should be the same. Put your answer over there. Next one, number 4. Sort of the same idea, except this time they say in the diagram that this is an angle bisector, so we know that these 2 angles are congruent. If those 2 angles are congruent, then any point that's on that angle bisector has to be the same distance from that side of the angle as it is from this side of the angle. So we know that these 2 expressions have to be equal to each other. So 6x plus 3 has to equal 3x plus 6. I'm going to solve this. Subtract 3x on both sides. End up with 3x plus 3
6, these cancel out. Add 3 to both sides, you end up with 3x equals 9. I'm sorry, that should have been subtract 3 on both sides. So you end up with 3x equals 3. Divide by 3, you end up with x equals 1. Once we know x is 1, we're trying to find the length of segment BD, that's right there, so we just plug in 6 times 1 plus 3. Plug that into your calculator, do whatever you need to do. That's going to tell you how long segment BD is, and that will be your answer. Number 5 says find the coordinates of midpoint of segment AB with these two vertices. We're going to use the midpoint formula. Midpoint formula again is you add the x's, divide by 2, add the y's, divide by 2, you get two separate answers. You get an x coordinate and a y coordinate for the midpoint. I'm going to start this off for you, then you can finish it. This is an x, that's an x, that's a y, that's a y. So we got negative 4 plus 8 divided by 2, and you got 0 plus 3 divided by 2. Do this math, negative 4 plus 8, get that answer, divide by 2, that's going to tell you the x coordinate, 0 plus 3, add those together, divide by 2, that's going to tell you the y coordinate, and that's going to give you your answer. Next one, they tell us that N is the end center. As soon as you see that it's an end center, you should remember back and think, all right, if that's an end center, then each one of these coming out through here has to be an angle bisector, which they show you by their markings on the angles. Also, we had an end center theorem that said that the end center is always the same distance from all 3 sides of the triangle. So those 3 distances all have to be the same. This time they tell us that ND, that's that segment, is 4x plus 5. I think that says 4x plus 5. Is this segment, and it's 7x minus 10. Pretty sure that's supposed to say 4x plus 5 there. We set up the equation because we know those two have to be equal to each other, so 7x minus 10 has to equal 4x plus 5. Subtract 4x on both sides. End up with 3x minus 10 equals 5. These cancel out. Then you add 10 to both sides. End up with 3x equals 15. Divide by 3. And you end up with x equals 5. They ask us to find the length of segment NE. Well, NE is that segment right there. They didn't tell us anything about segment NE, but they did tell us, or we do know that those 3 segments are all the same, so if we find one of them, then we'll know all 3 of them. So it doesn't matter which one we plug into. I'm going to plug into this one right here, and I get 4, x is 5, 4 times 5 plus 5, figure out that, and that's going to tell you how long segment NE is. Next one, they tell you that in triangle LMN, P is a centroid, so that's a centroid right there. That tells us that all 3 of these segments are medians, and if it's a median, that means C is a midpoint, B is a midpoint, A is a midpoint. So these 2 are congruent, these two segments are congruent, and these two segments are congruent. They tell us that VP is 3. We probably don't need all the information that we just found there, but we know it all. We had the centroid theorem that said if this segment is 3 from the centroid to the side, the segment from the centroid to the angle has to be double that. So if this side over here has to be double 3, let's take 3 times 2, and that's going to give you the length of segment LP. That's one of the things we're trying to find. So whatever you get there, that's one of your answers. Then once you find this segment, you're going to add that segment LP plus your segment here, which was BP, which we knew was 3, and that's going to give you segment BL, the whole thing. That's your other answer. So you want those two answers, and that's going to tell you which one of these it is. Number 8, point P is a centroid, so that's a centroid again, so same idea. That's a median, that's a median, that's a median, that's a midpoint, that's a midpoint, that's a midpoint. These two segments have to be congruent, those two have to be congruent, those two have to be congruent. Let's see what else they tell us here. They tell us the segment AN, so segment AN, that's this whole thing. That whole median is 18. So AN equals 18. Well, our theorem about centroids said that the distance from the centroid to the corner is 2/3 of that. So 2/3 times 18 would have to be segment PN, or segment, they actually name it segment NP. Same thing. And then this other part from the centroid to the side is 1/3 of the whole thing. So 1/3 times 18, and that's going to give us segment AP, how long it is. So you figure those two things out. When you plug this into your calculator, you can use the ABC button, or you could just do this one and know that, hey, if I'm multiplying by 1/3, that's the same as dividing by 3. So you just take 18 divided by 3. That's going to tell you AP. And if you find AP, you can just say the whole thing minus AP would leave you with segment NP up here. So those are going to give you your two answers. You can figure out which one it is. Next one, Park and Recreation Department wants to add some sidewalks to the park. The fountain F is located at the park's centroid, so they're telling us that that's the centroid, and is 85 feet from the entrance A. So this right here is 85 feet. That's this segment from A to F. It's 85 feet. Once we know that that's 85 feet, and this is the centroid, we know that this distance from here to there has to be double that. And that's what they ask us. How many feet of sidewalk are needed to connect the fountain to the gift shop? The gift shop's here, the fountain's there. So we're trying to find that, and all you have to do is double this one. So it's going to be 85. Doubling it means times it by 2. And that's going to tell you how many feet of sidewalk you need for that. The company builds trusses to support structures. In the truss shown below, the support segment GH is a mid-segment. That tells us that H is a midpoint, tells us that G is a midpoint. find the value of x. So we're just trying to find x this time. Well, if g is a midpoint, then that means these two segments are congruent. And if this one's 21, then you should know what x is, and that'll be your answer. Number 11. You install fencing around your large triangular garden. So you're installing fence all the way around here. All the way around this edge. Then you divide it into 4 small triangular gardens by connecting the midpoints of each side of the triangle with fencing. So we're also putting fencing around here. How many feet of fencing do you need? Well, if we know that this is the mid-segment triangle, because each of these is a midpoint. So this part over here, HB, is 17. Then that tells us HC has to be 17. And we know if GB is 19, then AG has to be 19. And the mid-segment theorem said that segment KH is half as long as segment AB. So this is half of this. Well, if this is 19, this is 19. We could add them up and divide by 2, but it's going to tell us 19 again, so that means this segment in here is 19. This is 17, this is 17, that means this mid-segment KG has to be 17. And then we know that this mid-segment is 21, so going backwards, if that's 21, then we know that these two segments out here are both 21. Now what we need to do to find all the fencing that we need is we're going to add up the perimeter for this triangle, so that means we add that, and that. And then we're going to add that to the perimeter of this inside triangle. So the 17, the 19, and the 21. We add all those up, and that's going to tell us how many feet of fence we need. Number 12. List the sides of triangle ABC from shortest to longest. When we're listing these from shortest to longest, remember the shortest side's always across from the shortest angle. The longest side's always across from the largest angle. First thing we need to do here is add these two up. You get 123, and we can find this other angle by subtracting that from 180. So 180 minus 123, we have to borrow there, that's 7, that's 5, that means this angle right here is 57 degrees. And all we're going to do is we're going to figure out which one we want shortest to longest. So we want the shortest side first. Well, the shortest side is across from the smallest angle, and that's the 57 degrees. So the shortest side has to be segment AC, making sure that we use our symbols. Then the next shortest side is going to be across from the 60-degree angle. I messed up, that's not AC, it's supposed to be AB there. So that's segment AB, that's the one that was over here across from the 57. Then across from the 60-degree angle is segment AC. That's the middle side. Then the longest side has to be across from the biggest angle, which is the 63. So that has to be segment CB or BC. This should be your answer down here. They could have named the segments a little different. They could have switched around the A and the B on this first one, or the A and the C on the second one, or the C and the B on the third one. But it should be in that same order. Next one, list the sides from shortest to longest. Same idea on this one. That's the smallest angle, so this has to be the shortest side. biggest angle, so that has to be the longest side. That's the middle size angle, so this over here has to be the middle side. And you're gonna list them from shortest, so you wanna name these segments from shortest, then the middle one, then the longest, and that should be one of your answers down there. Next, we're putting less than, greater than, or equal to in this. We look at this, we know that this side's congruent to that side, this side's congruent to that side. And we can compare the two angles, the included angles, angle 2 and angle 1 are the included angles, the angles between those two sides. Well, we notice angle 1 is across from a side that's 18 units long. Angle 2 is across from a side that's 19 units long. Since this side's 19, it's larger than 18. That means angle 2 has to be bigger than angle 1. So that's the big one. Angle 1 has to be the smaller of the two. And we look right here, and we want to say the measure of angle 1 is either less than, greater than, or equal to. Well, this time it's less than. We want the less than, because angle 1's smaller than angle 2. Problem 15, same thing, only backwards this time. This time we're comparing segments instead of angles. We know these two sides are congruent, we know these two sides are congruent. Then we look at our angles, that's 75, that's 75. They're across from those two sides. So we can say AC here, it's across from a 75-degree angle, XY is across from 75-degree angle. Well, what that tells us, since those two angles are the same, then these two sides have to be the same. So those two sides have to be congruent to each other. And we could have figured that out just from this when we did proving triangles congruent in chapter 5. We have side, angle, side, so those two triangles have to be congruent. And that means that these two sides that are corresponding sides are congruent. So this time, instead of less than or greater than, your answer would be the two sides are equal to each other. Next one, number 16, same idea. Yeah, this side's congruent to that side, this side's congruent to that side. We look at the angles and compare them. This is 71 degrees. It's across from segment AD. The 70 degrees is across from segment CD. 71's bigger, so that means this segment right here has to be bigger. So AD has to be bigger than CD. You can figure out which symbol goes in there then. Number 17. You and your brother are going different places for the holiday, but you make the 25-mile drive due north to the airport together. You fly 225 miles at a 15-degree angle west to reach your destination. Your brother flies 225 miles, 25 degrees towards the east to reach his destination. Who is farther from home? I'm going to draw a picture up here. Help me explain this. So that this is your home. Together you both go 25 miles to the north to get to the airport. This is our airport up here with our plane. You fly 15 degrees. So that's 15 degrees. That's 15 degrees. You fly 225 miles. Your brother flies a little bigger angle. He's 25 degrees. He flies 225 miles. If you want to figure out, don't go by my picture who's farther. Alright, go by what you know. We know that you both went 25 miles, so this, in your triangle, this side is the same as that side in your brother's triangle. You both flew 225 miles, so those two sides are the same. So these are the included angles. The distance you are from your home is here. Distance he is from his home is here. Well, we know that his angle's 25 degrees, your angle's 15 degrees, so that means his has to be the longer distance or bigger, and yours is the smaller distance from your home. So your brother is actually farther from your home. Next one, the triangle has one side that measures 1 feet and another side that measures 20 inches. Anytime you have something like this, you got to make sure you have the same units, or you can't really do what we did with these kind of problems. So we want to change this 1 foot into inches, and we do that by multiplying how many feet there are times 12. So this is just going to be 12 inches this time. When we it says which are possible side lengths of the third side. Remember, we did this. We had the third side, and we used the alligator mouse. On this side, we said you subtract the two sides to find the number that goes on this side. On this side, you add the two sides. So over here, we're going to subtract them. That's going to be 20 minus 12, which is 8. And on this side, we're going to add them, which is 20 plus 12, which is 32. So we're saying that that third side has to be between 8 and 32. The third side's got to be between those. So you can pick out which possible lengths can be your answer. Next one, same idea, our third side. On this side, the lower end, well, first thing we got to do is we see 2 feet here and 11 inches. So we want to change this into inches. Well, 2 times 12 is 24, so that's 24 inches. So on this side, we subtract the 2, so over here we got 24 minus 11. Figure out what that is. That's going to tell you how low that third side can go. And on the other side, we got 24 plus 11. That's going to tell you how high it can go. Then you can figure out which of these numbers fall in it. Same thing on the next one. This time it says 3 feet, so 3 times 12, that's 36 inches. So our third side has to fall between, this time we got 38 inches minus 36. That's going to give us the low number over here. And then we got over here 38 inches plus 36. That's going to give us the high number over here. And we just see which of these numbers fall in between those two. And that's going to be your answer for number 20. Problem 21 through 24. I'm going to do just a couple of these. It says match the set of segment lengths below with its description. So they give us a set of segments on each one of these, and we want to match it with A, B, C, or D, and put our answer out here. The first one says segment, and I'm going to label this triangle ABC. I'm just drawing some random triangle there. They told us it had sides A, B, and C. AC is 10, BC is 28, and AB is 15. The first thing you should do when you get a triangle like this is make sure that it is a triangle. Now if I look at this and I pick the 10 and the 15, 10 plus 15 equals 25. We had a theorem that said any two sides of a triangle must add up to be more than the third side. Well, 25 is not more than 28. So these sides, these side lengths, cannot be a triangle. So B can't be the largest angle because it's it's not even a triangle. A can't be the largest angle because it's not even a triangle. C can't be the largest angle because it's not a triangle. And then D says the segments do not form a triangle. That's the one that we want. So our answer to that one is D. Now if we jump down to 23, I'll let you do 22 and 24 yourself. We draw another triangle ABC. This time they tell us that segment AC is 39, segment BC is 13, and segment AB is 29. We can check to make sure 29 plus 13 is 42. That's bigger than that, so that works. 29 plus 39 is 68. That's bigger than the other side, which is 13. 39 and 13 gives us 52, which is greater than 29. So these can be the sides of a triangle. Once we have this, up here we're looking for the largest angle. Well, the longest side is the 39. Which angle is it across from? Well, that's going to be your largest angle. So that's going to give you your answer. So here, angle B is the largest angle. That means that was letter A. That goes there. You can figure out the other two. Problem 25. Problem 25 says find the length of the mid-segment. So they're telling us this is a mid-segment. That tells us N and M are midpoints. We want to find the length. That means we're going to be using the distance formula. So first thing I need to do is I need to find the coordinates of some of these. Well, the coordinates of N are 2, 2. Coordinates of M are -1 and 1. Oops, the second one should be a +1. So -1 and 1. S, the coordinates are left 3, down 3, so that's a -3 and a -3. And T, the coordinates are right 3 and down 1, so 3, -1. Now, if this is a mid-segment, we had a theorem that said that mid-segment has to be half the length of this side of the triangle, or this side of the triangle is double the length of that mid-segment. So we really don't need to find both by using the distance formula. We find one, and then we can find the other by either doubling the length or taking half of it. And so what I'm going to do is I'm going to find the length of this mid-segment, and then you can double that to get the length of this. Or I'm going to go through and show you how to set this up, and then you can finish it out. Remember, the distance formula looks like this. X's go here, Y's go here. This is an X, that's an X. So it's -1 - 2. This is a Y, that's a Y. So it's 1 - 2. Do a little math here. -1 - 2 is -3. We're still squaring that. 1 - 2 is -1. Use your calculators. Squaring that. Then we do this. -3 squared is 9. -1 squared is 1. We add those two together, we get 10. Now I'm going to let you finish it from here. You're going to find the square root of 10. Once you find that answer, that's going to tell you the length of this segment. That's going to be one of your answers over here. Then once you find that answer, you're going to take that answer and you're going to times it by 2, and that's going to give you the length of segment ST, because it's got to be double the mid segment, and that's going to be your other answer.